Most of the time, when we're trying to describe something quantitatively, we'll just use numbers. Say you wanted to measure how much time has passed, or the temperature outside, or the amount of liquid in a glass. You could describe any one of these with a single number, like 1 hour, 60 degrees, or 8 ounces. All of these quantities are examples of something called a scalar. A scalar is simply a quantity with magnitude. It tells us how much of something there is. Say you're driving a car. Your speed is an example of a scalar. If your friend were to ask you where you're going and you just told them your speed, it wouldn't tell them very much. They'd still have no idea where you're driving to. For them to know this, we'd need something that tells them both your speed and direction. And this is where we can use vectors. Vectors are quantities with both magnitude and direction. You can think about them visually as an arrow, where the magnitude is the length of the arrow and the direction describes where it's facing. This is one way we can describe a vector. We start with a line segment pointing in no particular direction. Its length is the vector's magnitude. We'll then rotate that segment by a certain angle, giving it direction. In this example, the magnitude is your speed, and the direction describes where your car is facing. We can also describe a vector based on its coordinates. In other words, how fast are you traveling east or west, and how fast are you traveling north or south? These two pieces of information also tell your friend your speed and direction, and we call them components. By telling your friend either the magnitude and angle or the two components, they now know how fast and in what direction you're driving. In this case, we're only thinking about the 4 directions on your compass, but if your friend also wanted to know your altitude, we need to add another direction, up or down. Now, with these 3 quantities, your friend has even more information. This is what makes vectors so useful. We can use them to represent multiple pieces of information, understand objects' behavior, and make decisions accordingly. Together, scalars and vectors can represent physical forces, like speed, velocity, and acceleration, helping us understand real-world physical phenomena.